Dear students, I am Santan, working as a physics faculty in Target English Medium School. Today, in this part video, I would like to teach textbook oriented question and answers, mainly in the textbook also application oriented type questions, means which questions are application oriented type is there in the chapter of refraction of light at plane surfaces. That questions mainly we discussed in our previous video. Also we are discussed some of the application oriented question from the textbook, and today also the remaining questions we are discussing clearly. So that's why let me come to our topic. The next one is in the application oriented type questions. So take a thermocol sheet. Listen very carefully. First of all, we can take a thin thermocol sheet. It will be cut into the circular disc of radii, like 2 cm, 3 cm, 4 cm, 4.5, 5 cm, etc. Marks its centers with sketch pen. Now we can take the needle of length nearly 6 cm. Pin a needle to each disc at its center vertically. Take the water in a large opaque tray and place the disc with 2 cm of radius in such a way that the needle is inside the water as shown in the below figure. I will withdraw what is that figure also. Now try to view the free end of the needle from the surface of the water. So means here you are observing that clearly. What is that one means? First of all, we can take a thermocol sheet, that is they are given that. After taking the which one? Thermocol sheet. This thermocol sheet you are cut into the different radius. Like for example, 2 cm, 3 cm, 4 cm, 4.5 cm and 5 cm, like this one they are given that. So first of all, we can take the length of rectangle shape of the thermocol sheet, because of thermocol sheets are in rectangle shape mostly. These sheets you can cut into the different radii, like 2 cm radii of one thermocol sheet, next 3 cm, 4, 4.5, 5 cm. Like that radius of sheets you can cut from this one. After that, what we can take? Now we can take L, that is equals to H of the needle. Length of the needle nearly what is that one? 6 cm. Now we can take the 6 cm length of the needles. That needles you can fix for the 2 cm, lower one 3, 4, 4.5, 5. For example, it is the 2 cm radii. For this one you can fix the 6 cm. Next, for example 3. Next 4, 4.5. Next 5, like this one. So what is the meaning of that one means here? Just this is the thermocol sheet of the radii which one 2 cm. It is the radii of 3 cm. It is the 4 cm, 4.5 and 5 cm. So like the radii of this one, we are considering that. For each radii of the thermocol sheet, you fixed 6 cm at its center, 6 cm length of the needle. For each one, 2 cm, 3 cm, 4, 4.5 and 5 cm of the radii of the thermocol sheet. For each and every thermocol sheet, we fixed 6 meter length of a needle at its center. Not at the upper portion, it is fixed at the lower portion of the thermocol sheet. After that, first what they are asking that, first of all we can take the 2 centimeter radius of the r is equals to 2 centimeter. 2 centimeter radius of the thermocol sheet. For this one, we fix which one? One iron nail. What is this length or h is equals to 6 centimeter. Length of the needle or height of the needle from this one, because of in vertical mode the length or distance we can say as a height or okay. That's why length of the needle, that is nothing but height of the needle from the lower portion to this one is 6 centimeter. This one is slowly placed into the large trough. It is contained the water. We know that the thermocol sheet is in light in weight, its density is less than the water, so that the thermocol sheet is float on the water. At that time, are you able to see the head of the needle or not? First thing, in which cases when we fix 6 centimeter length of a needle to the 2 centimeter radius of thermocol sheet, that is keep onto the surface of the water. At that time, so our observer is where? Observer is in the rarer medium. Then the needle is in which one? Denser medium. Now we can try to see the needle, head of the needle from the rarer medium to denser. Do you see this head of the needle or not? That is the first question. Yes, we are seeing the head of the needle. Why? Because of means we know that by the which process? Refraction. From this one, some light rays will be fall here. When the light ray will be fall here, for this one, the thermocol sheet is acts as an obstacle. That's why the light will be reflected to back. One more ray we can consider like this one. Okay, so the ray which will be fall here. In this one, the light rays are coming from the head of the needles. This light ray behaves as to travel from denser medium to rarer medium, because of here it is the air, it is the water. Air is a rarer medium, water is a denser medium. That's why it will be refracted and reaches to the observer. This one. So that's why we can able to see the head of the needle very clearly by the which phenomena? Refraction phenomena. Listen very carefully. First of all, we can take a thermocol sheet. The thermocol sheet we can cut into the different radius, 2, 3, 4, 4.5 and 5 centimeters like that one. After that, now we can take the so 6 centimeter length of the needle. The needles are fixed at the lower portion of the each and every radius of the thermocol sheet. It is nothing but for 2 centimeter one, for 3, 4, 4.5, 5. For each radius of the thermocol sheet, we can fix exactly at its center or middle. After that, so the first question is, so what is the first one? So now we can place the 2 centimeter radius of the disc on the surface of the water. The disc is nothing but thermocol sheet. The thermocol sheet is already fixed with which one? In this sheet already fixed the needle of length 6 centimeter. That's why when the 2 centimeter radius of the thermocol sheet is slowly placed on the surface of the water, it will be float on the water because of the thermocol sheet density is less than the water. That's why it will be float. At that time, now you try to see the head of the needle inside the water. Is it possible to see? Yes, it is possible to see. Why? Because of due to the refraction only. How means like this mode. Answer is first one only the S. What is that question? First they are asking that, are you able to see the head of the needle? Yes, we are able to see the head of the needle because due to the refraction process. That is the one. Okay. For first question we can write the answer which one? S. We are able to see the needle due to the refraction phenomena or due to the refraction. That is we can write. Next the second one is, at what maximum radius of the disc we are not able to use the or see the at what maximum radius of the disc we are not able to see the free end of the needle. So listen very carefully. It is nothing but you are taking the 2, 3, 4, 4.5, 5 like that one is there. Not only that one, number of like that. But in which radius of the disc we are not able to see the 6 centimeter length of the head of the needle. We are not able to see in which case, that is the okay. So that's why you are observing here very clearly in this time. It is the trough. Okay, in the trough, it is the radius of the which one disc. We don't know what is its radius. From the center, it is the head of the needle. From the head of the needle, it is the surface of the water. We have mentioned that here. Surface of the water. S dash S is there. Now in this one, it is the head of the needle. We are consider that surface like this one. Okay. Like this type of mode, you are observing that it is the radius of the disc. So it is the L, that is equals to H, is nothing but length of the needle. So this value we don't know. This is which side. In this one here, from the head of the needle, we consider one ray like this one ray like this one. Here, what will be formed? Here you are observing that it is the O, it is the A, it is the B. A, O, B. It is a right angle triangle. Is it correct or not? That one I will draw in large way. It is nothing but in a magnified way. It is the O, it is the R, it is the A point, it is the B point. Here angle C. So why angle C means we know that. Okay. This angle we don't know, that's why I can say as a angle C. It is the L, that is equals to H, that is we know that. So it is the head of the needle. This is the center of the radius of the disc, that is we know that. So finally anyway, A, O, B is appears like a right angle triangle. In this one. So now first you can find this one by using the which way? So by using the Snell's law of refraction. Here light is a travel from where to where? The light is a travel from denser medium to rarer medium. So what is the question is asking that at what maximum radius of the disc we are not able to see the free end of the needle. So it's nothing but you are not able to see the head of the free end of the needle means what is the meaning of that? The light will be not reaches to you by the refraction. It's nothing but the light ray will maybe occur. Okay, so it will be follow the critical angle or TIR, total internal reflection. It's nothing but in this surface of the water. It is the disc is there. The light will be fall like this one. Grazes to the surface. Okay, or one more way I can say like this one. So it's nothing but the angle of incident. We know that in the denser medium is equal to the critical angle. The refracted ray is become to the 90 degrees is nothing but it is grazes to the surface. Is nothing but no part of the light is enter into the which one? Rarer medium. Just it is passing through. But the angle of incident in the denser medium is greater than the critical angle. No part of the light is enter into the rarer. It is must be enter into the same medium only. So that is we know that. Now here is also what we discussing that at what radius of the disc we are not able to see the free end means what is the meaning of that one? The angle I we can say as the angle C because of at that time only the refracted ray is not enter into the rarer medium. Listen very carefully. At the critical angle or more than the critical angle, the light ray is not enter into the rarer medium. If the light ray is not enter into the rarer medium, the observer cannot be able to see the head of the needle. Why? Because of if the light is reaches to the observer by the refraction, at that time only he was able to see the one. Due to that reason, we are considered here, this is the angle, this is the angle C. That's why the refracted ray is not reaches to the observer's eye, it will be grazes to the surface. Due to that, here the angle I is greater than the angle C, then the light will be reflected to back in the same medium only. Anyway, in the two cases, the observer cannot be able to see the which one end of the needle. But what is the radius of the disc? This radius we are find out that. So for finding out that one, so we know that what is that one. For this is the theta, we can say that for the theta, it is which one? Opposite side, it is the adjacent side, it is the hypotenuse. That's why we find this value. Okay. So first we know that what is that one means. So according to the Snell's law of refraction, N1 sin I is equals to N2 sin R. That is, we know that N1 is nothing but denser medium, N2 is the rarer medium, because of light is travel from denser medium to rarer medium. Angle I is in the denser, angle R is in the rarer. So anyone here, N1, okay, sin I is equals to, here I is nothing but what is that one? Critical angle C. We have said that sin I is nothing but sin C. So N2 is nothing but refractive index of the air. What is the refractive index of the air? 1. We know that. Into sin R. Sin R means at the critical angle, the refracted ray is grazes to the surface at that time. What is the refracted angle? 90 degrees. Sin 90 is 1. So that, what you can write? Okay. Sin C is equals to 1 by n. N1 is nothing but 1 by n. We can write like this. So sin C is equals to 1 by n. This is, we know that it is the which one? Critical angle. The relation between critical angle and the refractive index of the medium, it is represented. Or directly we can write, but by using the Snell's law we can do that. Sin C is equals to 1 by n. Sin C is nothing but sin I or sin theta. This is nothing but like this one or not? Sin theta is equals to opposite side by hypotenuse. So sin C equals to 1 by n. Opposite side is nothing but r. R is equals to what is that one? 1. We can set that here. Hypotenuse. Hypotenuse is nothing but what is this one? N. So sin theta equals to opposite side by hypotenuse. Then so now, okay, sin C equals to 1 by n is compared with this equation. Then what will be happen? So opposite side means what is there here? 1. Hypotenuse is nothing but what is there? N, a refractive index. That is why n we are writing here. Now, what is the n value? N is equals to 4 by 3. Why n is equals to 4 by 3? The refractive index of water is 1.33. 1.33 is nothing but 4 by 3. So that's why means the refractive index of the water, we know that clearly. That's why refractive index of the water is 1.33. It should be right 4 upon 3. Now, so R value is 1 is nothing but opposite side value is 1. And okay, this hypotenuse value is 4 by 3. Then what about the H value? So H value is, we can write simply 4 upon 3 whole square minus 1. By using theorem, Pythagoras theorem. By using the Pythagoras theorem, we know that. Okay. So we know already OB value and AB value. We find which value? AO value. So due to that one, so what is according to the Pythagoras theorem? AO square is equals to, okay, OB square minus AB square. Generally, what is the main Pythagoras theorem? OB. Hypotenuse square is equals to, so means OB whole square is equals to, okay, so we know that AB square or OB square minus, plus AB square, like this one. Is it correct or not? So here we are observing that not OB, so OA, AB, OA. So hypotenuse square is equals to adjacent square plus opposite square. Is nothing but OB square is equals to OA square plus AB square. This is one. But here we know the already OB value. Next AB value. We don't know which value, OA value. That's why. So here, but actually L is equals to H. That is, you know that H equals to 6 centimeter. But okay, what they're asking that at what radius of the disc? At what radius of the disc we are not able to see the free end of means for H. Okay, that's why you can find what is this height. Okay, at what concept? At the which one? Okay, critical angle position or observing or not. At critical angle of position means is nothing but okay. So the light is not enter into the rarer medium. That's why you are not see the which one head of the needle. But here, what is the question means at what radius of the disc, the 6 centimeter length of the needle, you are not able to see. That's why. So now in this one, this radius of the centimeter means from this one also you are considered. This is the H or L, length of the needle or height of the needle. Okay. So that is lateral we are considered here. But if you are considered the length of the needle, this Pythagoras theorem we are not using, but it is very other mode is there. But what is our concept here? So opposite side is 1 by using the Snell's law of refraction. Why? Because of means light is travel from denser medium to rarer medium. So that's why here we are using the two ways. It is the first way about the light travel from denser to rarer at the critical angle position. That's why. So AO square is equals to OB square is there. This AB square is transferred to the left hand side, becomes to the minus because of your plus. Then OB square minus AB square. So AO square is equals to OB. O to B is nothing but 4 by 3. 4 upon 3 whole square minus AB is nothing but 1 square. So square is transferred to that side. AO is equals to root of 4 upon 3 whole square minus 1. That's right. AO is nothing but H according to this one. So that's why. Okay, H you can live with it. Not is the L, it is the H we cancel. L is the length of the pin. That is we cancel laterally. H. That's why. What is the H value? Okay, means AO value 4 by 3 whole square minus 1. So from the diagram, from triangle AOB, from the right angle triangle AOB, tan C is equals to, tan C is nothing but we know that opposite side by adjacent side. What is the opposite side? R upon H initially. So R upon H means from the diagram, okay, 1 by, so it is the 1, it is the 1. Actually this is what you are considered R. That's why 1 upon H means what is the root of 4 upon 3 whole square minus 1. So it is the R. This value you can say as a 1. So now you are considered only these values. Listen. Tan C is equals to R upon H, that is equals to 1 by root of 4 by 3 square. Now from this one, R is equals to, H is transferred to the right hand side. H upon root of 4 upon 3 whole square minus 1. This is 1. Okay. Now that is equals to, H is equals to 6. Why? H is equals to 6 centimeter. Is nothing but, that is nothing but length. Okay. So the length or head of the needle, here we are considered that. Okay. So what is our main motto here? At what radius of the disc, or is the radius of the disc? At what radius of the disc is nothing but for this one total. At what radius of the disc? Okay. So, but here 1 is there means this one. Why I will be considered by using the Snell's law of refraction. When the light is travel from denser to rarer at the critical angle, you can find this one. Okay, so but our main concept is what is that one? At what maximum radius of the disc we are not able to see the free end of the needle. That's why in this concept we consider the needle. This is not about the needle concept. It is only belongs to which one? Okay, it is this diagram is only belongs to the critical angle concept when light travel from denser medium to rarer medium from the head of the needle. But this is belongs to which one? Okay, so above this is the radius and what is the length of the needle. That's why R is the radius of the needle and R is the radius of the disc is nothing but thermocol sheet and H is the length of the needle. The length of the needle is 6 upon 4 by 3 is nothing but root of 4 square means 16 upon 9 minus 1, that is equals to 6 upon root of 16 minus 9 upon 9, that is equals to 6 by root of 16 minus 9 upon 3. Because of this root is belonging to total, that's right. So root of 16 minus 9 upon 9. This value we can write root of 16 minus 9 upon root 9. Root 9 is nothing but 3. It is bring to the numerator side. 6 into 3 upon root of 16 minus what is that value? 7. Okay. So here we are observing very clearly that is equals to 6 into 3 18. 18 by root 7. This value is nearly 6.8 centimeter. 18 by root 7. Root 7 is nothing but 2.86 like that one. So that's right. 18 by root 7. Okay. So not. So 2.68 something will be there. So anyway, so root 7, 18 by root 7 is equals to 6.8 centimeter. Is nothing but what is the radius of the disc? 6.8 centimeter. Is nothing but when the thermocol sheet radius of the disc is 6.8 centimeter. At that time, you are not able to see the 6 centimeter length of the head of the needle which is present inside the water. Is nothing but the radius of the disc here to here. This radius of the disc is 6.8 centimeter and the length of the needle is 6 centimeter. At that time, the head of the needle we are not able to see because of this one. The light is coming from this one is obstructed by the which one? This radius of the disc completely. Here we are considered that first diagram is, don't be confusion here. It is the O, A, B, we consider that. It is the R, it is the N, it is the H, we consider that. It is the C. So actually this diagram is not belonging to the radius like that one. This diagram is belonging to about which one? When the light is to travel from denser medium to rarer medium at the critical angle concept. So means I will be draw simply for you understanding. So here it is the normal, we consider that N. It is the O. It is any one point, we consider that A point. So from here O, one light ray will be fall here. It will be grazes to the surface like this one. In this one we are observing that, is it correct or not? So it is the H we can say, it will like we can say as a R, it is we don't know, that is we can find here OB. That's why what I say that means here R is the radius of the not thermocol sheet. In here R is represented the radius of the or distance of the light from the which one? Intersecting point. Understanding here R is not represented the radius. Listen very carefully. R is not represented the radius. This R is represented which one? The length of the incident light fall on the refracting surface when the light is travel from denser to rarer. At that time, the distance between center point or intersecting point to incident path point of the light. This is nothing but point of incident. The distance from point of incident to intersecting point of the okay, SS dash and NO. That's why this is the R. What is this value? 1 centimeter. We can say that we are finding here. This is the N we can find. What is the refractive index of the water? 4/3. That's why refractive index of the water is 4/3 and R is equals to 1 and H value is root of, okay, we know that this value is 4/3, this value is 1. How we can find this value is 1? By using the Snell's law of refraction. H value is root of 4/3 whole square minus 1. That's why this diagram is represented about the light is travel only from radar to denser at the critical angle position. Based on this one, next cases we are using the tan C is equals to R/H. R value from this one is 1 and by H is nothing but root of 4/3 whole square minus 1. That's why tan C equals to R/H, that is equals to 1 by. Now we are cancel these two values. Then okay, so this H is transferred to the right hand side. Then R is equals to H upon root of 4/3 whole square minus 1. R is the radius of the disc. Here R is the distance of the point of incident of the light obliquely onto the which one? For critical angle position. Simply R is the distance of the point of incident of the light at the critical angle. Here R is represented the radius of the disc. That is the small difference. That's why, so we know that the first question is, okay, are you able to see the head of the needle when at 2 centimeter radius of the disc? Yes, we are able to see the needle due to the refraction phenomena. Second one, at what maximum radius of the disc we are not able to see the free end of the needle is nothing but at when the radius of the disc is 6.8 centimeter. At that time we are not able to see the head of the needle. Next one, why we are not able to view the head of the nail for certain radii of the disc? Because of light is not reaches to us or TIR is occurs. So the third question is in the same one. What is the first one is, are you able to see the head of the needle? Yes, we are able to see the head of the needle due to the refraction. Second one, at what maximum radius of the disc we are not able to see the head of the needle? 6.8 centimeter radius of the thermocol sheet we are using. At that time we are not able to see the head of the needle because of the light is coming from the head of the needle is obstructed by the which one? Radius of the disc, because of when compared to the length of the needle, radius of the disc is more. Next, in the same question, third one is, what is the third one means? So why we are not able to see the head of the needle in certain cases? Okay, so means when the head of the 6 centimeter length of the head of the needle we fix to the 2, 3, 4, 4.5, 5, 6 like that one. During such type of condition, in certain times, why we are not able to see the head of the needle means, okay, at that time, okay, the light, okay, coming from the head of the needle is not reaches to us, is nothing but, okay, TIR is the occurs. That is the answer. That's why when the TIR is the occurs, the light ray is not reaches to us. That's why we are not able to see the which one? Head of the pin. That is the third one. Next, for the fourth one, draw a ray diagram or draw the diagram to showing the passage of light ray from the head of the nail in the different situations. In the different situations. That's why for the fourth one we discuss the three cases. We can draw the diagram for showing the passing of the light in the different situations. So the first one means A, we can say that radius of the disc is less than the 6.8 or 6 centimeters. Simply, it's nothing but radius of the disc is less than the 6 centimeters is nothing but length of the disc. That is the meaning of that. Understanding? Okay, radius of the disc is less than the length of this one. Then what will be happen? radius of the disc is less than the 6 centimeter, means this one. Which one? Radius of the disc is less than this one. Then what will be happen? Okay. So this is the R, radius of the disc. R is the length of the head of the needle. That's why the radius of the disc is less than the 6 centimeter, or this one, R. Okay. One more thing, we're discussing that here. Another mode. So here, one small correction. R is less than the 6.8. Why we are using the 6.8 here means at what maximum radius of the disc we are not able to see the head of the needle 6.8 centimeter. That's why the radius of the thermocol sheet or the radius of the disc is less than the 6.8. When the R value is equals to 6.8, we are not able to see. Or if R value is more than the 6.8 also, we are not able to see. But when R value means is nothing but radius of the disc is less than the 6.8, what will happen? You are able to see. When you are not able to see, when the radius of the disc is 6.8 or more than 6.8, we are not able to see. But less than the 6.8, we are able to see. That's why. So what will be happen? It is the light. You can say that. It is R is equals to less than 6.8 centimeter. At that time, light will be fall here like this one. Refract. Like this mode also. Like this one. This is the ray diagram for which one? When the radius of the disc, this radius of the thermocol sheet disc is less than the 6.8, we see the head of the needle from either left side or right side when the observer is there. Next one, B. If R is equals to 6.8 centimeter, is nothing but radius of the disc is equals to 6.8 centimeter. What will be happen? When R is equals to 6.8, then what will be happen here? Mostly the light is abstracted by R. Mostly the light will be not enter into the which one? Denser area may become denser. Listen very carefully. If R is equals to 6.8, mathematically I will prove that when the radius of the disc or radius of the thermocol sheet is 6.8 centimeter, at that time we are not able to see the head of the pin. Means what is the meaning? Most of the cases at that time, the light is not enter into the radar medium, is nothing but so the light will obeys the critical angle. That's why this is the position of the light ray. Next, C. If R is greater than 6.8 centimeter, is nothing but the radius of the disc is greater than the 6.8. At that time, what will be happen? So TIR is occurs. R is equals to greater than 6.8. At that time, TIR is occurs. Listen very carefully here. So if radius of the disc is less than the 6.8, we see the head of the needle by the refraction process. If R is equals to 6.8, at that time the light is not entered into the denser medium. We are not able to see. At that time, light is grazes to the surface. If radius of the disc is greater than 6.8, at any view we are not able to see the head of the needle because of light is nothing but TIR is occurs, is nothing but total internal reflection is occurs. That's why light is not reaches to our eye in any way. Next, one more question. Place an object on the table. Look at the object through the transparent glass slab. You will observe that it will appear closer to you. Draw a ray diagram to draw the passage of light ray in that situation. Listen very carefully. You are placing one object on the horizontal surface of the table. Now in front of the object we place a rectangular glass slab. Now we can try to see the object. Now we can see the object through the rectangular glass slab. At that time the object appears closer to you. For that one you draw the diagram. Already this concept we discussed in the previous. What is that one? In case of normal shift or vertical shift produced by a glass slab, because of by the refraction process, it is not appears at the actual position, it is appears to closer to the refracting surface, by which phenomena? Refraction phenomena. That's why here is also that phenomena will be appears, but you can draw one diagram for showing that which one object is closer to us. That's why. It is the object. From the object you can say as one point. In front of this one, at one particular place, we place a rectangular glass slab. It is the rectangular glass slab. So an object which is placed in front of the rectangular glass slab. From one point we can say, from that one, okay, from this one we draw a normal for the which one? Refracting surface A, B, C, D. Okay. The corners or vertices of the rectangular glass slab we can say as A, B, C, D. We draw a normal for the AB line. From this one we consider the one ray will be fall like this side and another one is the left hand side. One is from left, one is from right, another one is which one? Fall normally onto the AB surface. Listen very carefully. It is the object. It is the glass slab. Which type? Rectangular glass slab. So the rays are coming from the object mainly. So you can consider from one point on the object, one particle. This is represented the object. Now from this position of the object, you are considered the three rays. Number of rays are emitted, but we can consider the three rays for draw the diagram neatly. One ray will be fall normally. After the refraction, it is undeviated. Okay, one ray will be fall obliquely into the left side, another one is into the right hand side. Now, like this, we can consider that. So we know that the light ray is coming from the object. When it will be fall onto the AB surface, at this point, it behaves as to traveling from rarer medium to denser medium. It is the O. O is the position of the object, we consider that. That's why when the light is enter into the denser medium, we know that from rarer to denser, it will be bent which one? Towards the normal. Is it correct or not? So here is also when the light is travel from rarer medium to denser medium, it will be bent towards the normal. It is also bent towards the normal. Now here we are observing that that's why it is the which one? O dash. So here we are observing that when the light is travel from rarer medium to denser medium, so the light will be, what will be happen? Sorry, not this one. Sorry, not exactly this. A small modification is correct, but a small modification. The same previous diagram, but little bit modification for understanding of it clearly. Object. This point we can say as a O. Okay. Here we can say as a rectangular glass slab. Their vertices is A, B, C, D. From this one, like this. Okay. Where we are not in the denser medium, that's why we change the diagram. So previous one is in the denser medium. Actually, you see from inside, from CD side, you see which one object through that glass slab. That's why we can see that here. Slightly bend in this one. Here is also. So this is the refracted ray. When it will be fall at this point, okay, at this one, it is moved away from the normal. Why? We know that. What is the main reason here? So you are observing here, okay, when the light is travel, listen very carefully. The light is coming from the object. That light rays are behaves to travel from rarer to denser for the AB refracting surface, and the light rays are enter inside the glass slab and they will be travel inside, and they will become outside at the CD surface. The light rays which are come outside at the CD surface, they behaves like to travel from denser medium to rarer medium. That's why when the light is travel from denser medium to rarer medium, what will be happen? Okay, the light ray is deviate from its path and move away from the normal. That's right. So now this is the emergent rays. Finally, these rays are reaches to us. But these rays are after the refraction. They never meet at our eye. That's why where you can see the image, you cannot see the image in the side of the CD. You can see the image in the side of the AB only, or in the side of the object. But at which point means, okay, this one produced to backward. This is also like this one. This is O dash. So that's why object is at O, but this object is appears to where at O dash. Is nothing but O dash is near to the AB. Is correct or not? That's why this is the ray diagram. So listen very carefully. An object which is placed in front of the glass slab, but the object is appears closer to our eye or closer to the refracting surface to draw the diagram. Is it correct or not? Because of observer is inside, CD side is there. This is the way of the method to draw the diagram based on the refraction process. Next and last one is, how do you appreciate the role of Fermat principle in the draw the ray diagrams? So means I will draw one diagram like this one, or in case of, actually this concept is mainly useful for the concave is nothing but curved surfaces like convex concave mirrors, convex concave lenses. Mainly in that cases, Fermat principle is very useful to us to draw the ray diagrams. But here the question is asking, how do you appreciate the role of Fermat principle in drawing the ray diagram? Means first of all you can write the what is the Fermat principle. Means is nothing but first point is about the definition of Fermat principle. Fermat principle is says that when the light is travel from one place to another place, it is selected the least path to travel. That is the main. Select the least path. Second one, based on this one only, we are considered that light is always propagated in a straight line motion. It's nothing but in a rectilinear propagation. And the third one is, so this Fermat principle is useful to us to find where the image will be formed and what is the nature of the image. We can easily find by using the Fermat principle. These are the 3 points are we can mainly write for this one. What is the first one? Fermat is said that light is always select the least path to travel. And the second one is, so what is the second point? Means you can write about the, so the Fermat scientist says that first point is straight line only. Second one is what is that one? So due to that one only, means Fermat principle is also says that light is travel in rectilinear propagation. Rectilinear is nothing but straight line path only. That's why with help of the two concepts you can locate or show the what is the position of the image, and with help of that one we can find what is the nature of the image in case of convex, concave, mirrors or lenses. That is one. So once again listen. First one is Fermat is said that the light will be select the least path to travel. Second point is, so according to the Fermat, we know that light is travel in a rectilinear propagation. It's nothing but straight line path. That's why with help of the Fermat principle, so we can easily locate the position of the image and we can find the what is the nature of the image formed by the mirrors and lenses.